So here's the video for 9.3.2, but it's more of let me see if I can help you a little bit with 9-78. Now, I'm not going to complete the entire problem, but I'm going to help you out with the graphs. So one of the things that you're going to need to be able to do, definitely on this, is complete the graphs. You can find the resource page and the Desmos activity that goes along with this in 9.3.2 in the CPM online book. 9-78, there's a link for you. So you might want to pull that up and kind of have it ready as we're going. So we have this scenario where it's going to be a search and rescue situation. So what I've gone through is I've pulled out portions of the book. This is also in the 9.3.2 notes page. So if you don't want to print it off on Schoology or off of the CPM site, that's totally fine. You can pull this off of our school closure calendar. So I figured what I would do was take a snapshot of the things from this that we really, really, really need. And then I'm going to go ahead and color code things to kind of help us out. So we've got these 3 note cards that are given to us. So these guys down here, so these 3 note cards. And we're going to follow those to try to figure out where on earth the people are located that we're trying to find based off the search and rescue. So now would be a good time actually to pause the video and go ahead and read this question for yourself, 9-78, kind of wrap your brain around what we're looking for. And when you're ready to continue, go ahead and unpause the video and we'll pick right up and we'll start working on the graphs. Okay, so now I did say that I was going to help you with the graphs, which I'm going to for sure. But what you're going to need to do is you're going to write the constraints. So in the your task part, you need to complete the constraints to give them a system of inequalities. So the constraints would be like y is greater than or equal to 7. Y is less than or equal to 2/3 x minus 9. So stuff like that. So basically, we're going to go through and we're going to create the graph itself for each one of these cards. Then your job, my recommendation to you, is to pause the video at that point, really look at the graph, figure out what the boundary is. So remember, the boundary would be the equation of it. So if it were an equal sign, what would it be? And then using the shading to try to figure out what the inequality should be. So if you haven't watched the 9.3.1 video, especially at the very end, we did stuff just like that. So you want to make sure you kind of have that on cue for yourself. All right, so let's take a look at the very first one here. Let's dissect this card up here. So we know where it left. It left from the northern tip from the airport. Okay, so that's important. At the northern tip of the Philippines. So I'm going to go over to my map and I'm going to start at the northern tip of the Philippines. And then you'll notice that on the legend for this, or the key for the map, they did tell us what the airport looked like. So I know up here I have, so my little orange dot right there is going to be the Philippines up at the very top left. Flight was supposed to follow a straight path. Okay, so straight line directly to, all right, we're going to the airport in French Polynesia. Okay, so we know what their path was. So I'm going to start at the Philippines and I'm going to go down to French Polynesia. So I'm going to find the airport at French Polynesia. I'm going to go ahead and color code that orange as well. So direct path. Now, I don't know if this is going to be an equation or if it's going to be less than or equal to, greater than or equal to, greater than or less than. I don't know if it's going to be solid or dashed. So I'm just going to go ahead and fill in a solid line, and then I'll go back and erase chunks of it if that's not the case. Okay, so I'm going to start up at the top at the Philippines, and I'm going to draw my line down to French Polynesia. Okay. So there's my line, as best as I could. Then Balloon's last known location was at -1,000, 1,000. Okay, and each one of these grids is a 1,000 mark. So they were spotted right where I just put my orange X. All right, so it was on a balloon. Okay, so let's see. Do I want this to be equal to or not equal to? Well, I know this direct line path is what they were supposed to be on. So, I mean, it could be that they were there. So I think I'm going to leave it as equal to. Okay, so I'm going to leave it as equal to. But that location of negative 1,000, 1,000 is telling me that I think they are either going to be still on their path where they were expected to be, or they're actually going to be lower than that. So in the direction of where that is. All right, so I think I'm going to shade down here. So there is my first graph and my first inequality. So now would be a perfect time to go through and identify what the equation of this is. Now, a little bit of help to you. If I take a look at this, now I know my graph's not perfect, but I think it's pretty close. It looks like it has a y-intercept right there at what would be 2,000, because every block is 1,000. And it looks like it has another point right down here, or pretty close. So I think by using those 2 points, I have the y-intercept. I also have the slope of my line. And I do think that I want to keep it as an equal to, because they could be on that path. Hopefully. We'll see. Okay, so go ahead and pause. See if you can write the one for this. And I'm going to go ahead and move to our next slide. Okay, so now here I've got my graph from the previous one already set up. So now I'm just trying to build on top of this. Okay, so if I build on top of this, now I'm at the green one. So a different piece of information. They were on their way from Australia. Okay. Saw a hot air balloon sinking rapidly. Okay, I'm certain. All right, so it's from Australia. So let's start at Australia. So the airport in Australia down here. And then I'm certain it crashed south of our flight path. Okay, that's going to help us when we go through and do our shading. South of our flight path. When we left Australia, it traveled 2,000 kilometers north for every 3,000 kilometers east. All right, so 2,000 north, so 2 boxes, because every box is 1,000, and then 3,000 east, so 3 boxes east. And then just as a reminder, so if we have our little navigational map for this, so put a little navigational map up here, then we have north, east, south, west. So we want to go north, so up on the paper, and east, right on the paper. So we're going to go up 2,000, so up 2, and then right 3. Oh, that's nice. That gives us the y-intercept. Okay. Oh, I think we also have a slope now. This is very good. So 2, and then 3, and then 2, and then 3. So just like previously when I graphed stuff, I kind of want to make sure that I cover my coordinate plane, except I'm not going to go on the other side of the airport in Australia, so to the left, because we know they didn't go that way. Okay, I'm going to go ahead and connect the dots here, and then let's see. Well, this isn't the path that the hot air balloon was on, so I don't think they're actually on the path of this one. But I do think that they are, let's see, it's south of their path. So let's see what we should do here. I think we should go ahead and connect the dots. And I think we should shade south, so down. Okay, all right, let's do that. So let's go ahead and make a dashed line. Ooh, let's use a different type of marker here. So a dashed line through this. And we want to go south. So I'm going to go down from there. Okay. All right, I see an overlap happening. That's good because we're trying to actually triangulate where the hot air balloon is. So take this opportunity, go ahead and pause, and write the constraint for the green graph that we just put. So we know where the y-intercept is. Remember, every box is 1,000. And we also know what the slope is because that's what we did when they told us to plot the north 2,000, east 3,000. And did say that they were south of them. So we don't think it's actually on that path. So it's not going to have an equal to sign. Okay, let's move on to the next one. Okay, here I've got my shading and my work already done from my previous two. I'm just kind of building on top of this. All right, let's see what the next one says. It was a passenger on a flight. They flew from French Polynesia to Indonesia. Okay, so French Polynesia. So let's find them. French Polynesia, okay. From French Polynesia. So purple dot on the right-hand side to Indonesia. Purple dot on the left-hand side. And let's see, I was looking out my window when I saw the balloon going down to the north. Okay, so it wasn't on this path either, but it was north of them. All right, so I think what I'm going to do is I'm going to connect these with a solid line because they're so far apart from each other. I figure if I do a dash, it's going to look kind of wonky and I don't want to worry about that. So I'm going to do a solid line, but then I'm going to go through with my eraser and I'm going to erase chunks of it because it did say that it was north of where they were flying. So I'm going to connect these two airports here. Then I'm going to go through with my eraser and I'm just going to erase little chunks of the purple line. Now, if I had more points in between them, I don't want to touch that green one. I probably would have gone and done a dashed line, but my hand gets a little shaky. I think kind of everybody's does if you don't have a ruler with you and you're just trying to create a straight line. So with a dashed or with holes in it. All right, and then it said that it was north of where they were flying. Okay, so we're going to be above this purple line. All right, so above the purple line. So let's say I'm going to stay above the purple line. Okay. And then from here, I really do want to take a look at this and kind of see where this thing is focusing in on. But before I worry about and it's called your feasible region. So where is the likely location of the hot air balloon? So we've triangulated its position. But before we do that, now would be a good time to go ahead and pause the video and write the inequality that goes along with your purple. And then if you take a look here, this one actually worked out kind of nice. It looks like we have a y-intercept at 0, 0. And then I think we could do slope. So let's see. There's another point just before we get to French Polynesia. So I'm going to go ahead and label those as point A on my graph and point B on my graph, just because it's getting a little crazy looking with all the different lines and shading. So I know that gives me the y-intercept, and then between A and B, I can find the slope. And then my shading is, so think about where it's located, and we know a possible point that works up there, so figure out what your inequality is. And then there's little chunks or holes missing, so I don't think it's supposed to be equal to. Now, if we wanted to clean this graph up, that's where our feasible region is. So that's where all of the overlapping is going to happen. And it looks like, I think it's under there somewhere. in my shading, it looks like they're probably in the Isle of Samoa. So at this point with the graph, you should now be able to, or have hopefully been doing, the constraints as we've been going along. And then the majority of today's assignment is kind of a combination of this and then stuff that we did in the 9.3.1 lesson.